Hey gang, this video is a reminder of how to use Logger Pro to analyze your parachute video. The first thing you need to do is open Logger Pro. Once you've done that, you'll select Insert Movie. At this point, you will search the computer for where you saved your video file. You should have emailed it to yourself, or your teacher may have already uploaded it for you onto a computer. My video is called Parachute, so I will select that and click Open. Here you can see my parachute video, and I'm just going to move it to the middle and make it a little bit bigger so that it's easier to analyze. Now remember the steps for making sure your video is at the right place. First, I'm going to hit the play button and watch my video quickly. I can see that in the beginning, the parachute moved horizontally a little bit before it actually started to fall. I can show you that in slow motion. So what I want to do is I want to make sure that I am analyzing the data before the parachute starts to move. So what I want to do is I want to analyze the data after the parachute starts to move. Right about here, it seems to begin to move in the downward direction. So I'm going to call this my beginning position. Then I'm going to select from the bottom right side of the video the triple red dots. When I do that, a toolbar will appear on the right-hand side. The first thing you need to do is set the scale. Remember to do that, you select the horizontal ruler in yellow on the right side. Once you've selected the set scale, you're going to click, drag, and highlight the object that you are using as a reference point. Mine was a meter stick, so when I release, I will tell the computer that this was 1 meter in distance, and I will select OK. Now I will tell the computer where the origin is. To do so, you're going to select the button that has the green axes on it that says Set Origin. When you do that, select the position directly beneath your parachute on the ground where your parachute should land. Now you can see these yellow lines which represent the horizontal and vertical axis. Now I'm ready to begin collecting points. To do so, I'm going to select the red button that says Add Point, and I'm going to place a dot on the part of my parachute that is most recognizable. So for me, it's the orange ball. Once I click on the position of the orange ball, the computer is going to place that position on the graph behind me, and then it's going to move to the next frame. So I'm just going to continue to click on the bottom of the orange ball as it falls through space until it gets to the ground. So you'll do the same. Make sure when you're doing this, you are trying to select the same point on your parachute every time. If you're using the top of the parachute, just make sure you're selecting the same point on the top of the parachute as your parachute falls to the ground. Once the parachute gets to the ground or close to it, or at least to the x-axis after you've set your origin, you can now begin analyzing your graph. We're done with our video. So you can click on the graph, and remember, we don't really care about the horizontal motion, so I'm going to select from the y-axis just the y direction. So now I have the position of my parachute in meters, and I don't have anything about the horizontal, which is good. Once you've done this, you're going to eyeball where you believe your parachute started to move in dynamic equilibrium. I can see in the beginning that there's a slight curve, and we need a constant slope. So I'm going to select, drag, and highlight the region of my graph that I think is dynamic equilibrium. Once I've done that, I'll select the R equals button, which is the linear fit, and I'm going to check out the correlation here. You can see my correlation is 0.9996. So I'm going to click and drag my position of my highlighted region to see if I can get that number any closer to 1. So here we're at 0.9997, 0.9998, and that seems to be as good as it's going to get. So I'm going to move to the position that's earliest in time that has the highest correlation. So this drops me down to 0.997, so I'm going to go to the 0.9998. At this point, I can use this data to collect for recording the slope of my graph, as well as the correlation, and the time where my parachute reached dynamic equilibrium. Once you've recorded all of this data on your worksheet, you can change the graph to show the velocity time graph by selecting the y-axis again, selecting y velocity, and again you're really just considering the time of the graph where it looks like your object was in dynamic equilibrium. Right now it looks a little funky, so if I click on my y-axis, you can see I have this little squiggly line here. If I go up so that there's a squiggly line in a bar, I can scrunch this up so that I'm seeing a less zoomed in version. And this is going to give me more of the graph that I want. And so you can see in this highlighted region, and if I can click and highlight again, this line is relatively flat, as it should be, because the velocity should be constant during this time, since our parachute was in dynamic equilibrium, or it reached terminal velocity. To check that, I can check out the slope. Right now my slope is 0.6. That's kind of high because we want the slope to be 0. So again, I can adjust my zoomed in section by selecting that bracket and adjusting it until I get an average slope that's closer to 0. So that's a little bit better. And now I can use this data again to include in my CER conclusion about how well my parachute worked.